Rolle's theorem states if a function is continuous on the closed interval a to b, then if the y values at the endpoints match, which is what I see here, there is at least one number c inside that interval, so not including the endpoints, such that its derivative equals 0, meaning it has a horizontal tangent line, meaning it has a max or a min, either one. My diagram has a max, because if those endpoints have the same y values, at some point in between them, I need to turn. So I've got to turn around, and that's going to create a max or a min with a horizontal tangent line. So the derivative has the slope of 0. Okay, so what can we do with this? Find the two x-intercepts of this function, x squared minus 3x plus 2, and show that the derivative equals 0 at some point between the two intercepts. So basically we're going to solve for that x value. We're going to solve for c. So what we're stating here is that these intercepts, those are x-intercepts, both have a y value of 0. So they have the same y value, so in between them there must be some point where I turn around, creating a max or a min. So first we've got to find the intercepts. Well, those occur when y equals 0. And I need to factor this thing to get to them. So what multiplies to 2 but adds up to negative 3? Negative 1 and negative 2, which gives me intercepts of x equals 1 and 2. So our interval here is going from 1 to 2. So the x value we're solving for must be in between 1 and 2. So then we're saying that the derivative will equal 0 at the point we're looking for. So I need to take the derivative of this function. Take the derivative of x squared, I get 2x. Negative 3x gives me minus 3, and the derivative of 2 is 0. So we set this equal to 0. Solve for x. I add 3 to both sides and divide by 2. I get x equals 3/2, which is the same thing as 1.5, right? Which is right in the middle of the interval. So that's the value I'm looking for. So for this parabola, which opens up, I know that just because I know my family of graphs, there's going to be a minimum at x equals 3/2, which is in between the intercepts that are occurring at 1 and 2. Then we have the mean value theorem. If a function is continuous on some closed interval from a to b and differentiable, then there exists a number c in between a and b such that the derivative evaluated at c, that would be the slope of the tangent line at c, right? Is equal to, well, look at this. What is this? That's the formula for slope. And it's the slope of the line in between the points A, f of A, and B, f of B. So if I draw that line here, I'm not doing a very good job, but that's a secant line, right? A secant line is a line that passes through a curve at two different points. So we're saying there's going to be a slope of a tangent line somewhere in between A and B that is equal to the slope of that secant line. From A to B. Well, right here, whoops, I didn't mean to move that. If I draw the tangent at that point, see it's parallel to my secant line. Okay, and how did I know exactly where to draw that? Because, you know, I mean, how did I get it perfect? This is the graph that goes with the next example, so I already know where that point was. Okay, so our function, which I just showed you the graph of, is f of x equals 5 minus 4 over x. Find all values of c on the open interval from 1 to 4 such that the derivative of c equals the slope for those points going from 1 to 4. So first we need to find what f of 4 minus f of 1 over 4 minus 1 is. That means I've got to evaluate the function at 4 and at 1. So f of 4, if I plug a 4 into my function up here, 4 over 4 is just 1. I get 5 minus 1 is 4. Minus, if I plug a 1 in here, 4 over 1 is 4. And 5 minus 4 is 1. I get 3 over 3 is 1. So we want to find all x values in between 1 and 4 where the derivative equals 1. So we need to take a derivative. All right, so the derivative of 5 goes to 0. The derivative of negative 4 over x, well, that's the same thing as negative 4x to the negative 1, right? Negative 1 comes out front. That's going to make that positive 4 x to the negative 2 or over x squared. So we want to know for what x values is 4 over x squared equal to 1. If I multiply both sides by x squared, we get x squared equals 4. Then x equals, when you take a square root, what do you put in front of it? Plus or minus 2. But look at our interval. I only want x values that are in my interval from 1 to 4. So it's only positive 2. So we're going to say that our c, our x value, is 2.